All right, guys, so we are going to talk about some more things today. We have undefined terms, defined terms, and postulates. So I have my composition book out. You should have too. So let's go ahead and start here. So we'll start with undefined terms. So undefined terms. All right. Undefined terms. Now that might sound a little unusual if I say that a term is undefined. This is what I mean by undefined. When you look in a dictionary, you look at the definition of a word. Suppose I want the definition of the word, I don't know, term. All right. So when you look at the dictionary, it gives you a definition. Well, guess what? The definition is in terms of other words. Well, an undefined term is something that's so basic you can't define it using other terms. That's what a dictionary does. A dictionary defines words using other words. But with undefined terms, we can't do that. So let me show you what I mean. And these are some pretty basic stuff that you probably already know about. So let's see. And let's make our definition a little precise here. So undefined terms cannot be defined. Cannot be defined from other figures. So cannot be defined from other figures. I say figures because that's what we're going to be talking about. We're going to have three of these, okay? A point, a line, and a plane. So let's start with the first one. A point. What is a point? Well, a point is simply a location in space, right? You could say it's a specific location. So a specific location, all right? A specific location, and we'll make it a little more interesting. I could also say it has dimension 0. So when I say dimension 0, I mean you have 0 degrees of freedom. All right, I can't move left, I can't move right, I can't go up and down, I can't go forwards or backwards. I'm stuck where I'm at. I have 0 degrees of freedom. So that is a point. And there's a couple ways you could write this. If I were drawing a picture of a point, so a picture would be something like this. I would just draw a dot and I would label it. So point P. If you were writing it out in words, you could just write it out. You could say point P. And I'm going to do this on each one of these because sometimes they'll show you a picture and sometimes they'll actually have a paragraph and they'll talk about it that way. Okay, so let's see. So that's a point. I think we're good on that. Let's move on to lines. Lines are cool. Don't forget about lines. All right, so a line. Well, a line is a connected straight path. So it's a connected straight path. Now, this is a little different from the usual world. Usually in our everyday world, a line ends somewhere, right? Like, I drew a line down here. It started and it ended. This is different in Euclidean geometry, all right? Because it actually continues forever. So a straight path that continues and I probably misspelled that, but that's okay. Continues forever in both directions. And that's also important, both directions. All right, so a line is a connected straight path that continues forever in both directions. And I would say that that has a dimension of 1. So before we had 0 degrees of freedom. Now with a line, I have 1 degree of freedom. It's either left and right, it's either up or down, or forwards or backwards. And I can say left and right and say that it's just one because it says forever in both directions. So there's a couple ways I can write this. Again, I could do a picture, and usually they'll have something like this. Let's see, point P. We'll call these points A and B. How about that? All right, so we got points A and B. So they could draw a picture like that for you. They could talk about it in a paragraph or in a question. They would say, actually, a couple of different things they could say. Like, they can actually label this whole line. Like, I could label this line L. And usually they'll do like an italic, kind of fancy looking lowercase. So just think fancy lowercase means a line. So I have a fancy lowercase L. So they could say line L. They could say line AB. Or they could say line BA. Because it doesn't really matter if you start with A or if you start with B. It doesn't matter which one you start with, okay? Because again, it says forever in both directions. So the starting point doesn't really matter. There's no starting point. It's forever in both directions. So you can say AB or you can say BA. Still the same line. There's another way you can write it. The other way you can write it is this. I could say AB with this fancy little thing on top. If you can't tell, remember we talked about the biconditional? Well, it's basically that same symbol when it says you can go either way. Well, it's the same symbol here because it's both directions. I can go either way. So AB extends in both directions. That's why we have that. And again, because it's in both directions, it doesn't matter which one I put first. So I could also say BA. I could say that and then put my little symbol on top with my little two arrows. So you could do either one. So okay, so those are lines. Let's move on to planes. Let's see if I can draw a plane. That'd be interesting. All right, planes. So what's a plane? Plane. Okay, so basically it's a flat surface that extends forever. So extends forever in all directions. All right, so all directions. And I could also say that this is considered dimension 2. Now, okay, so think to algebra, all right? Yeah, algebra. You always use the Cartesian plane, that xy plane. Um, so xy plane, so you got something like this, right? All right, so you got your x, you got your y. They call that an xy plane. And notice how it extends forever. All right, it extends forever. You can go as far, you can make a function go as far away as you want, okay? That's what we're talking about a plane. It just goes on forever. We only draw a small little portion of it, but it's understood that it spreads out really far. All right, that's a plane. And so again, there's a couple of ways we can talk about it in our two-dimensional plane here. All right, so let's see here. A plane, you could either use an uppercase, fancy, italic letter, so I'm just going to use R. For some reason, we always use R for planes. We like to use R. I don't know why. It's just a habit, I guess. So, and I need 3 points. Notice how I'm defining this with 3 points. Notice how my line I define with only 2 points. My point I define with 1 point. There's a certain pattern to this. All right, so this is a picture of a plane. And I can call this a couple things. I could say plane R. Let me try and make it a little more fancy. So I could call it plane R. Or I could call it, I could say plane XYZ. All right, so 2 different ways I can actually write this out in a paragraph. So that is a plane. Now, so far we've gone up to 2 dimensions. Euclidean geometry actually, it does talk about 3 dimensions. And just a quick little note here. Euclidean geometry, why do I call it Euclidean geometry? Well, that's what y'all are doing. There's 2 different kinds of major geometry here. There's Euclidean geometry, and then there's non-Euclidean geometry. Euclidean geometry, so Euclid, he was a Greek who lived during Ptolemy I. So that would have been about 300 BC. Yeah, right around 300 BC is when he lived. So Euclid was this guy who actually wrote this stuff down, but he came up with an axiomatic system. Because remember, we talked about proofs, mathematical proofs. Well, he was one of the first ones to actually write actual, real mathematical proofs. In fact, his stuff was so good, they actually used it all the way until the early 20th century. So that's why we call it Euclidean geometry. So that's an important word. Euclidean geometry. Euclidean, all right? It's named after Euclid. Very important guy, don't forget it. Without him, you wouldn't be here. All right. So we have points, lines, and planes. Again, these are undefined terms. Notice I don't define a point in terms of a line. I haven't defined a line in terms of a point. All right, all of these are just self-contained. I didn't have to talk about points or lines when I defined a plane. That's why we call them undefined, because I can't define them in these other terms. It's not like a dictionary. We look up a word and you define something in terms of other words. That's why it's undefined. So those are undefined words. How about defined terms? So let's move on here. Defined terms. All right, defined terms. So I'm just going to give you a couple to start out with. The first one we have is line segment. Oops, that's not how you spell line. Let's try this again. There we go. Line segment. So a line segment, portion of a line consisting of 2 endpoints and all points in between. So notice this is the defined term because I actually use the term line, all right? So if you have something that you're using undefined terms in, that's when it becomes defined. So because I'm using the word line to define something else, that's why I call it a defined term. All right, so we could draw this a couple ways, just like before. Let's see, I already used AB. How about CD? So this would be CD. I could also call it segment CD. I could call it segment DC. And I could also call it CD with no arrows because I'm not extending infinitely in this direction. I'm not extending infinitely in this direction. So I don't have arrows. I just have a solid line and that's it. Or I could switch the order. I could call it DC. Because again, the order here doesn't matter. Now there is something where the order does matter. It's called array. So let me put array. So for array, so array is a portion of a line. So array is a portion of a line that starts at a point. Sometimes we call it an endpoint. So I'll just say that endpoint. And continues forever in that direction. So continues forever in that direction. So notice in this case, it doesn't go in both directions. It only goes in one direction. All right, so let me draw you another example. We use CD. How about we use EF? So this would be a ray. Think of it like a ray of light. All right, a ray of light, it starts at one point, and then it shines outward in one direction. So that's why we call it a ray. So it starts at E, goes through F, and it just goes on forever and ever. Let's see, for this one, we could say ray EF. Now, I can't say ray FE. If I say ray FE, that means that it would start at F and go in this direction. So like before, I can switch these around. For array, I can't do that. My endpoint comes first. E is my endpoint. That's what I write first. Or I could also say, I could write like this. I could say EF with an arrow going in just one direction. So I got an arrow going in just one direction. That would be array. So that's ray EF. All right. So we have the postulates. Let me go over those real quick. I'm just going to give you two postulates to start out with. So postulates. Postulates. So postulates are basically axioms. We already talked about axioms. So, and remember, axioms are things that are basically statements that require no proof. Statements that we believe without proof. Those are axioms. Postulates are basically the exact same thing. Because us mathematicians love postulates, because we love Euclidean geometry so much, we have a special name for axioms. We call those postulates. Because Euclid called them postulates, so why not call them postulates? But postulates are basically axioms. It's the exact same thing. Postulates is just a special little term for geometry that we like to use. So I'm going to give you postulates for lines. So here's the ones for lines. I'm just going to give you two of them. I know we don't have a whole lot of time in the video. So a straight line segment can be drawn joining any 2 points. A straight line segment can be drawn joining any 2 points. That's the first postulate. Now, notice how, again, we said axioms are pretty obvious. They're usually pretty obvious. This is pretty obvious. A straight line segment can be drawn joining any 2 points. All right, because you can show that with a ruler, right? Draw 2 lines, use a ruler, bam. You have a straight line with 2 points. Here's the second one. Any straight line segment can be extended indefinitely. So that means it can go on forever. Indefinite. I think I spelled that right. In a straight line. So remember, line segments, that's a line that has a start and a stop, right? It has two endpoints. Just a line, like this is just a line. If I only say a line, I mean something that goes on forever in both directions. I mean this goes on and on and on in both directions. All right, that's a line. So in the homework, I'm going to ask you the question. I'm going to say this. Prove, there's that word again, prove any line, not line segment, okay, any line. Prove any line can be drawn using 2 points. And you can prove this using these two axioms right here. So just write a paragraph, all right? Just write a paragraph. And the big deal is this. Which axiom are you going to use first? That's the big deal. Which axiom do you use first? All right? So I will let you get to it.